We today are going to look at graphs and the graphs of their derivative and interpreting them. So for our first example, we're given the graph of f of x. We want to graph f prime of x, okay? And f prime, that's the derivative, okay? The derivative is always equal to the slope of the graph at that specific point. So first thing I'm going to do is look at my graph of f of x and mark the points where the slope is 0. That would be like your turning points where you're flat. Remember, slope of 0 is like a horizontal line. So at x equals 0, I have a slope of 0. So I'm going to transfer that over to my graph of f prime. Okay. So on this graph, the y values are the slopes of this graph. Okay. And so then at 4, I also have a slope of 0. Okay. And then I'm just going to look section by section. So if I look here, okay, if I look at the slope of the graph, this is an increasing function. So all of these slopes are positive. Okay. So up until 0, I want to have positive slopes. So that means the graph of the derivative is going to be somewhere up here because these are all of the positive values. Okay. So I have got positive slopes once I get to 0. Okay. Then if I look here, this section of the graph is decreasing, so the slopes are negative all the way down to 4. So down here I want to go below the x-axis. I'm going to have to turn around, okay, so that I'm going to get to 4, okay, because at 4 the slope is 0, so you have to get back to this point. Then if I look at the graph after 4, it's increasing, so all of these are going to have positive slopes. Okay, so after 4, I want to be above the x-axis, so all of these y values would have positive slopes to them. Now let's look at one going the other way, or actually let's do one more just regular graph of f. Okay. So given the graph of f, graph f prime, so the slope. Okay, so I'm going to look at this graph right here. I have a slope of 0. So when x equals 1, I know the slope is 0. So I want the y value to be 0, because on our f prime graph, okay, the y-axis is the slopes of this graph. Okay, so that's why I have a point here at 0. Okay. Then if I look on this side, these are all negative slopes because the graph is decreasing. Okay, so over here, I want all my y values to be negative, so it means it's going to be below the y-axis. Then if I look on the other side, this part of the graph is increasing, so all of my slopes are positive. So after 1, I want my graph to have positive slopes, meaning the part of the graph needs to be above the y-axis. If you look here at all of these points, you have positive slopes. If you come back to this graph, you can see these are all positive slopes, and they're getting steeper and steeper, meaning they're getting more and more positive. Now let's go the other way around. Okay, so now they've given us f prime. Okay, so this is the slope. Okay, so like if I go to x equals 2, the slope would be about -2.5. Okay, on the graph of f. Okay, so we're going to work our way to going from the graph of the derivative to the graph of f of x. Okay. So I'm going to make my chart from the graph. Okay, so first we need to find where the slope is 0. Remember, like our first derivative test, we take the derivative, set it equal to 0. So if I look here, the slope is equal to 0. And if I look here, the slope is equal to 0. Okay, so we're not looking for where this, where like we have turning points on the graph. Okay, because this graph represents the slope. Okay, so this is saying at 0, the slope is 0. At 6, the slope is 0. So those are our two critical numbers. Okay, so f prime of x is equal to 0 at x equals 0 and x equals 6. Okay, so those are the two numbers I'll put in my chart. Okay. Then if I go back to the graph, Okay, I just need to figure out my plus or plus and minuses. So here I have all negative y values. So here this is telling me that f prime of x is negative because all of the y values on this graph are negative. So up until 6, the slope is negative. Okay. Then up until 0. Then if I look at this section of the graph, okay, look at your y values. Again, they're all negative. Okay, so we're still negative. So this tells me I'm decreasing. I'm still decreasing. And then if I look at 6, this graph goes above the y-axis. So this part, the f prime values, they're all positive. Okay, so I can see on the graph of f of x, I'm going to have a minimum value at x equals 6. Okay. Now we're going to do the second derivative. That'll tell us about the concavity of the graph. Okay. So to get our possible points of inflection, that is where f double prime of x is equal to 0. Okay. And f double prime of x, okay, that is the slope of f prime of x, okay, because it would be the derivative of the derivative. So now for f prime, or for f double prime, we're looking for where it's 0. So we are looking for where the slope of f prime is equal to 0, which would be here at 0 and here at x equals 4. So those are your two possible points of inflection. So f double prime of x is equal to 0 at x equals 0 and x equals 4. Okay, and so again, this is, we're making a chart for f double prime. I'm looking at f prime, so I need to be asking myself, what is the slope of this graph? Okay, so here I have positive slopes, so that means f double prime is positive, because f double prime is the slope of this graph. So that's going to tell me f of x concave up. Then if I look between 0 and 4, this graph is decreasing, so it means the slope of f prime is negative. So f double prime will be negative, meaning our graph is going to be, of f of x, is going to be concave down. And then after 4, it starts increasing again. So that's a positive slope. Okay. So we know f will be concave up there. Okay. So now we can take all of this and put it on the graph. So here's where my concavity changes. So I'm going to have a point of inflection at x equals 0, and I'm going to have a point of inflection at x equals 4. So what I need to, the 3 points I'm going to have on the table, or on the graph, sorry, are at x equals 0, x equals 4, and x equals 6. Okay, so we're going to have 3 points. Okay, they don't tell us the y values of these points. Okay, so x equals 0 is the smallest one. So I'm going to just pick a place to start. So I'm going to pick right here. Okay. And I know that I'm decreasing all the way up until 6. Okay, so my next point is going to fall at 4. So if I'm decreasing up until 6, that means the point at 4 is going to have to be below. And actually, I'm going to move my points up a little bit since I'm decreasing. Okay. So I'm actually going to start up here, and then I'm decreasing all the way to 6. So my point at 4 needs to be somewhere below, and then my point at 6 needs to be somewhere below my point at 4. That way, from 0 to 6, I'm decreasing. Okay. Then I'm going to go here for my concavity. So I'm concave up. So up until 0, it's concave up. Okay, so I'm decreasing and concave up. So I need to start up here so I can decrease. And then it'll be concave up. From 0 to 4, I'm still decreasing because 0 to 4 would fall in this interval. But then 0 to 4, you're concave down. then I'm still decreasing. This would be 4 to 6, which falls in this interval. But after 4, you switch back to concave up. So this part's going to be concave up. Okay. And then after 6, this is the only place that I'm increasing. So now I need to start going up. Okay, and I'm still concave up because 6 would be over here. And there is your graph of f of x.